Okay, we're going to take a look at a little review of series now. And for an example here, if we start with a square of 1 unit by 1 unit, cut it in half, and cut the remaining half in half again, cut that 1/4 in half, and so on, keep adding half of the remaining amount. We could do that indefinitely. We have an infinite series. There's always a little bit more that we could cut in half. And furthermore, if we add together all of those fractions over and over and over again, they would eventually add up to 1. So we say that this series is an infinite series, and it converges to 1. And there are many series that do not converge. For example, 1 over 1 plus 1/2 plus 1/3, so on. If we keep adding those up, those will add up to infinity. Okay, here's a general form of an infinite series. The terms are a sub 1, a sub 2, and so on. A sub n is the nth term. And we can look at partial sums, so adding up the first term, the first 2 terms, the first 3 terms, or the first n terms. And if we take the limit as n approaches infinity, the series converges if that goes to a single number, otherwise it diverges. Okay, a geometric series is one where you multiply each term by a constant value. We call that number the multiply by r. And a geometric series converges to a over 1 minus r. A is the first term, r is that common ratio, and this only occurs if the absolute value of r is less than 1. If the absolute value of r is greater than or equal to 1, the series diverges. And that makes sense because if you're multiplying by something greater than 1, you're getting values that are bigger and bigger and bigger. If you add those all up, those are going to diverge. And we call these values of r from -1 to 1 the interval of convergence. Anything between -1 and +1 will cause the geometric series to converge. So here's a geometric series because each term comes from multiplying the previous term by 0.1 or dividing by 10. And you can see if you continue this pattern out, 0.3 plus 0.03 plus 0.003, we get 0.3 repeating, which is 1/3. And if we use our formula to find what a geometric series converges to, our initial term is 3/10, our common ratio is 1/10, simplify this down, and we would get 1/3. So we can see that that matches up with what we would expect. Okay, geometric series multiplying by -1/2. Notice that r is negative in this case. We find this converges to 2/3. We can find a partial sum of a geometric series, so rather than adding up infinitely many terms, we could stop at some value of n. And if we take that value of n out to infinity, as long as r is less than 1, we'll see that a number less than 1 raised to the power of n as n approaches infinity, that goes to 0, and this becomes a over 1 minus r. Confirms that formula that we already had. And now we can go ahead and let that common ratio be a variable x. We'll make x any number less than 1. And we can find this connection here that 1 plus x squared plus x cubed for any value of x between -1 and +1 is equal to 1 over 1 minus x. And so we can actually use this as an approximation. We can turn something like 1 over 1 minus x, which is not a polynomial, we can essentially turn that into a polynomial. It would be an infinite polynomial if they're going to be exactly equal to one another. We could use some number of terms if we want to come up with an approximation. The more terms you use, the better the approximation. Okay, so if we're looking at convergence of a series, the first thing that absolutely must happen is the terms themselves must approach 0. So we know that our series diverges if we take the limit as n approaches infinity of a sub n either doesn't exist or is not equal to 0. And we can think of this just in terms of the terms. If we keep adding up numbers and they're not approaching 0, those numbers are going to add up and create a larger and larger and larger sum, which would cause it to diverge. But what's really important to note is the nth term test can show that a series diverges, but the nth term test absolutely does not show convergence for a series. So remember, we have to distinguish between a series and a sequence. A sequence is just the values of the individual terms. The series is the sum of the terms. Okay, so if we have the sum of n factorial times x to the n, x is greater than or equal to 1. Well, n factorial keeps getting bigger and bigger, x to the power of n keeps on getting bigger and bigger, so this series diverges. Okay, we have a telescoping series, which is a series where the middle terms essentially cancel each other out. So if we expand this series, we get 1 minus a half, plus a half, minus a third, minus a fourth, and all of those terms cancel each other out. If we look at the nth term, well, that last term that's not canceling out is getting closer and closer to 0, so this series adds up to 1. So here's our general form for a telescoping series. And we know that this always converges to the first term minus the limit of the last term. So as long as that last term is approaching 0, this will converge. Okay, harmonic series is this one right here, where you're just increasing the denominator by 1 with each term. And this series diverges. Diverges very slowly, but it does keep on getting bigger and bigger and bigger, even though each term is approaching 0. So we'll look at these partial sums. And what we notice here with the fourth sum, 1/3 plus 1/4 is greater than 1/4 plus 1/4, which is a half. So we know that the fourth sum is 1 plus 2/2. We can continue this out and keep grouping together terms. And you can see that we start with grouping 2 terms and then 4 and then 8 and so on. And as we do that, we can always end up with another group of terms that adds up to 1/2. So we have 1 plus a half plus a half plus a half, and we can keep doing that indefinitely. So we know that this limit equals infinity because we're going to keep on adding more and more and more terms. So the harmonic series diverges.